pleased to introduce you to our speaker, Phil Bell. Phil has been working in capacity management since leaving university in the year 2000. He started as a junior consultant on the niche platform of Unisys ClearPath Systems and rapidly moved on to capacity planning for distributed platforms as well, and gained VMware VCP qualifications in 2007. He joined the Athene team that year and left his role of capacity manager at an FTSE 100 company to become their pre-sales consultant. In addition to supporting the EMEA sales team, Phil is also involved in consulting, training, and assisting product management. He's had a number of papers accepted for regional and international CMG conferences, mostly on the topic of VMware and capacity management. So I'm pleased to turn it over to Rich Fronheiser from SyncSort and Phil.
Hi, I'm Rich Fronheiser. I'm a director of product marketing for SyncSort, and Phil and I both became part of SyncSort last year upon the acquisition of Metron technology, Metron Athene, and many of you who are involved with CMG might be familiar with Metron because we'd sponsored CMG for many years, and we've been at many of the CMG regional shows as well. As part of SyncSort, who is SyncSort and why is Metron and capacity management part of SyncSort? SyncSort is an organization that organizes data everywhere to keep the world working. Big iron to big data is a fast-growing market segment, and we optimize traditional data systems. We deliver mission-critical data from these systems to next-generation analytic environments. Most organizations in the Fortune 100 have SyncSort software, whether it's our MFX product that does mainframe sort, or whether it's IronStream that moves data from the mainframe into Splunk, or Athene, or some of our data quality products. And I'll talk about a few of those products before we get into the main presentation as well. Go on to the next slide. So there are three key areas that SyncSort addresses, and you see those on the screen. You see Optimize, which SyncSort optimizes data infrastructure to help improve performance and control costs across the full IT environment, from legacy systems to the cloud. There's Assure. SyncSort Assure products increase data availability and provide security as data protection becomes essential. And SyncSort Integrate products seamlessly integrate mission-critical data from traditional data systems to next-generation analytic platforms, and applies market-leading data quality capabilities to deliver business insights that you can trust. Next slide, Phil. So these three areas consist of a number of different software solutions and a number of technology and business partners as well. The optimized area includes mainframe optimization. It includes Athene and cross-platform capacity management, which we're going to be talking about today, data warehouse optimization, and application modernization. The Assure products deal with high availability, disaster recovery, data security, and mission-critical data migration. The Integrate products allow people to move data, access, integrate machine data for security, IT operations, legacy data to the data lake, change data capture, high performance ETL, data governance, big data quality integration. So these three different areas of SyncSort and the use cases that they provide are very important in keeping modern data centers running. And we're going to talk about just a small portion of what SyncSort does today, and that's cross-platform capacity management with Athene. Products in these areas, some of these you might have heard of, some of you might work with in your organizations. In the optimized area, we have Athene and Athene Cloud, MFX, which is the mainframe sort product. ZP Saver enables MFX to do mainframe sort on the zip processors. DL2 is a product that allows you to essentially take older applications and have them work with DL2 instead of older databases. Zen's a network monitoring product, and then the Easy Suite is an optimization tool for IDMS and for DB2. The Assure products include Mimics, availability, disaster recovery, Move, along with IBMI products that do security. The Integrate products include IronStream and IronStream for IBMI, which allows us to get data from mainframes and IBMI into Splunk, DMX, Mimic Share, and then Trillium, which is a data quality product. We're going to talk mainly today about Athene and Athene Cloud, and we're going to talk about how you can do capacity management with VMware. And I think the next slide is the beginning of Phil's presentation. So just want to introduce Phil Bell. I've been working with Phil for a long time. Phil's very good with VMware and capacity management. And I hope you enjoy the presentation. And Phil, take it away.
Okay, thanks very much, Rich. Thank you all for attending. Yep, so I'm going to talk to you, as you might have guessed, about VMware capacity management. I think I've been well introduced already. There was a number of topics that were listed when you signed up, so that's just a slide going through those. But we're going to be looking at some of the things that could be misleading from the way we've looked at things in the past, looking at operating systems, some key metrics that are important when we're looking at VMware capacity. Falling out of that will be some information about how the CPU scheduling works and things like that, which is important to understand because those metrics are going to tell you something. CPU and memory, they're always the big hitters, aren't they? So there's a bit of memory in there, a bit of storage we're going to talk about from falling out of those key metrics. And then a small exercise I went through showing how to calculate headroom in numbers of virtual machines, which some may have issues with, but we'll go through what I did, and it can always be a discussion point later on. So we'll start off with the OS metrics. It's where we usually get data from. If you say you're going to go and monitor a server, typically you go to the operating system and get data back. But with VMware, this introduces a bit of a challenge. So what we've got on the screen. Let me get a pointer up. That would help. Okay, what I've got on the screen here is a sort of a timeline over 1 second. Okay, I've got two virtual machines. This line is supposed to be representing a CPU chart. And if I look at that first machine, the operating system, for the period of time that it existed, thought that it was using 50% of the CPU. But it only existed for 50% of the time in that second. The rest of that time, it's dormant, idle, whatever you want to call it. It's not doing anything, doesn't exist. So VMware would tell you, half of a half, that's 25%, right? So that's CPU for that VM's 25% busy. The operating system thinks it's 50% busy. We're already seeing a bit of an issue there. Another VM on the same box, if it ran for the entire time and it used half its CPU, VMware would also say it used half its CPU. So those numbers are going to match up sometimes. They're not going to match up other times, and it can get a little bit confusing. So we're going to have an issue there. If what we're going to do is monitor the operating system or what it thinks is going on, that's going to be one of our first issues. This is a chart obviously pulled out of Athene because that's the tool that we represent. And I know the numbers are small, but it's representing something, and it's a server I can show because it's a server that was running Athene in a client's environment. What I've got two lines. The darker blue line at the top, that's the data from our Windows data capture. The lower line is data captured from the virtual center. And you can see there's a difference. The difference is only 1.5%, but it's the percentage that makes a difference. There's about 35% difference at some points in this slide. And that continues. If you expand, it's not unusual, or it's not been unusual to see VMs where the OS thinks it's 70% busy and VMware would think it's 30% busy on CPU. That kind of thing happens, and it's not stable either. If you notice, there's quite a 1.5% gap there, and there's about a 0.5% gap here. So from point to point, you can't just say, well, it's going to be 30% more or less or whatever. It varies from one point in time to another point in time, how different those two numbers are. So it can be misleading. One of the reasons, or some of the reasons behind it being a bit misleading for CPU is that a virtual CPU in a VM, a physical CPU in the hardware is shared across many virtual CPUs. And you can only have a vCPU, a virtual CPU, mapped to a physical CPU at one point in time. So there's this kind of one-to-one thing going on. But you've got many virtual CPUs and only a small number of physical ones. So the way it does that is it time shares. It's called time slicing. You put a vCPU on a VM for a little while, you take it off, you put somebody else's vCPU on there for the remaining time, and so on. The problem is that means that times kind of no longer become constant. One of the things we used to be able to rely on in the universe was that time would stay relatively constant until we got near a black hole or something crazy went on. Okay. Well, for a virtual machine, they're pretty much always living near a black hole. Time is not constant. It's a terrible life for them. So we need to cope with that, the fact that time's not constant. And VMware have made improvements in that area, so that trying to keep the operating systems up to date, they're trying to make sure they know what's going on. So the problem only comes in any metric that relates to a time element. So CPU percent, because we've got CPU seconds is pretty much what we're turning into a percentage. IOs a second, whether that be to disk or over network. All of these metrics that have a time element, they can be impacted by this. It's not just CPU. So there's a way that it gets dealt with. If that was the sort of VM I had before, it was running for half a second, it was dormant and idle for the rest of the time. What VMware does is it's not that neat. It doesn't run for half its time and then it's idle for half its time. It's idle for a bit, it runs for a bit, it's idle for a bit, it runs, and so on. And what VMware does is when it first comes back alive, it issues a rapid series of clock ticks. So as if the CPU was running really fast. It issues all of these really rapidly to the VM to keep it up to date. Otherwise, its clock would very quickly go out of date, out of time. So time goes very fast, and then it goes at real time, and then it stops, and then it goes very fast again, and then it stops. So that's what the effect of time slicing is having. There's problems there that need to be resolved. So the first thing to try and help with resolving that is rather than looking at percentages, VMware like to talk about CPU megahertz. So we're going to go through a bunch of these kind of metrics that are key for VMware. Rather than percent, VMware like to use megahertz. And there's a bunch of reasons for that, and we'll go and talk about some of them. But it's going to help compare processor across different systems. There's an element, there's a metric called ready time, and it's a measure of CPU contention. And we'll go through that in more detail, but the more ready time you've got, the less happy your users are going to be. Memory doesn't escape having its own unique VMware metrics either. You can't just say, oh, it's using this amount. Okay, it's not quite that simple. So there are metrics called active memory that you can get at various levels. There's ballooned memory, and that's where we sort of rob memory from one VM to hand it to another. Like we have to share CPUs, we also might have to share space in memory as well. So we need mechanisms to make that happen. And as well as the balloon memory, we've got disk latency that I think we get better metrics from VMware than we perhaps do from some of the other more traditional platforms. It's not a lot that we sometimes get about latency and things like that for disks, so it's nice to have something a bit better to work with. So talking about megahertz versus CPU percent, right? This may seem very obvious, particularly when I draw it in boxes on a screen, but it does help to illustrate the point. We've got two hosts on this screen. One's only got 16 CPUs, the other's got 32. All the CPUs are probably the same power, but there's half of them as many on one host. If the 80% of the CPU on this host is being used by the virtual machines, that's fine. There's 20% headroom. our other hosts 100% empty, right? So if you're just looking at the percentages, you'd think, well, if this one fails, if host 2 fails, those VMs will fit on, oh no, they won't. They won't fit on there because we're looking at percentages. So what VMware gives us is this metric of megahertz, which obviously we can round up to gigahertz if we want to. That enables us to look at our systems to understand, will the workload from this particular host fit on that host? Are we all right in terms of, it's called the N+1 tends to be the phrase used in terms of clusters. So you've got a cluster, we're going to allow for one host to fail. So if our host fails, will all of our gigahertz usage fit on what remains? We should be able to work that out. There's another sort of situation where in the previous example, the gigahertz of the chips was the same, right? So it was just there was less of them in one system. And so we can look at things and we can assess if we've got enough gigahertz to do all of the work. But it affects things on a sort of a lower level as well, because we might have different power chips on different hosts. You can do this in a cluster. You can have clusters which have got different power processors in them. It's pretty rare, but you know, it's out there, it can happen, it helps to explain things. So here we have, as an example, a VM that we're saying is 80% busy in terms of its CPU, and it's on a host with sort of 3.2 gigahertz chips. Maybe it's got one CPU, maybe it's got two, it doesn't really matter in terms of this explanation. If something bad happens again, host 2 it's a terrible machine, it keeps failing. Something bad happens, okay, that VM has a vMotion event, it goes over there, because those chips are less powerful, we're saying they're 2.4 versus 3.2, 80% suddenly becomes 106%. The VM's going to be flat out trying to do its work, and we're going to have unhappy customers. The unhappiness will move with that VM, not just the fact that that host has failed. Now that only becomes a problem if VMs are moving between different power systems. So it might not happen very often in terms of vMotion events within a cluster, but if we're planning upgrades or if we're planning on getting rid of a cluster, and maybe we've moved a lot of stuff out to the cloud and we're looking at which clusters are cheapest to run and we're moving servers around or VMs around, then it's important to look at not just the total amount of gigahertz that you need, but have we got any VMs that are on the edge if we're moving them to lower power chips? Of course, all of this works on the VMware assumption that every megahertz or every gigahertz is born equal, right? We know that's not necessarily true. If we're using a previous generation chip on one server and then we've got a current generation chip, maybe a slower gigahertz, but maybe it can do more with each gigahertz, okay? So it's not a perfect solution. Gigahertz is fine, particularly if we're comparing across a cluster of things that are all exactly the same power, or if we're looking at systems that are sort of the same architectures, then that'll be fine. But as soon as we start to cross some of those boundaries, neither percent nor gigahertz is going to help you. You've got to understand the relative power of those systems using benchmarks or whatever it is that you want to do before you can decide whether that migration is going to be good. Obviously, you can't be doing that for vMotion events within a cluster, but if you're planning new clusters and things like that, then that's where that comes in, particularly if you're changing the architecture of the CPUs to a newer one. So I mentioned ready time very briefly before, and ready time is when a VM wants to do something but can't. So to help visualize that, I like to talk about it like you were driving a car. You're in the car, you're in the driver's seat, you're holding the steering wheel, but you're not moving. There could be all sorts of reasons why the car isn't moving at this point in time. It could be that you have pulled over to collect somebody from somewhere. So you are currently doing the thing that you want to do, which is to wait for somebody to turn up to get in the car. It could be that you've pulled over to do a phone call. Take a phone call. Again, that's something you've chosen to do. That's the thing that you currently want to be doing, is answering the phone, not driving the car. Or you could be stopped at a red light. That isn't something that you want to be doing. That is an external force has acted on you and said that you may not do the thing that you actually want to do at this point in time. All you want to do is travel forwards, but you can't. That's like ready time. The entire time you spend at that red light staring at it, waiting for it to change, is ready time. It adds time to your journey that wouldn't have otherwise been there and gives you no benefit at all. Well, VM's the same. They want to do some processing, they want to go ahead, but the hypervisor isn't giving them a virtual processor to be on, to be processed, to go and do the thing that they want to do. So that entire time that they spend, they're not waiting for I/O, they're not waiting for anything else, they are waiting for CPU time to be available to be processed. And it affects the transaction time. So your end users feel that ready time in the time it takes for whatever information to come back to them. It adds to that. Now, it might only add a few milliseconds on this server, but if it's a few milliseconds here and a few milliseconds on the next one, and a few milliseconds on the one after that, because they're all running in the same cluster and they've all got the same CPU contention, it can start to add up. So VMs don't get scheduled nicely one after the other. There's a line in there I've used that says, it's more of a stack than a queue. VMs with higher priority, with higher number of shares can get in first. If you've got a smaller number of CPUs, you're more likely to find CPUs to run on. So that's a key thing. CPUs have to all be scheduled at pretty much the same time. And there'll be an animation that's going to go through this, but I'll say it several times to make sure that people get it. It's a simplification. So those of you with deep VMware knowledge might rankle against that a bit, but essentially all the vCPUs, all the CPUs in a VM have to be mapped to physical CPUs all at the same time. So the more CPUs you give a VM, the less chance there is that that number of CPUs will be available in the hardware when it wants to process. So there'll be a delay. So the fewer vCPUs you have, the more chance there is that those number of CPUs will be available at any one point in time. So there's less chance of getting ready time, which means there's less chance of having a performance impact. So just throwing vCPUs at VMs willy-nilly will not be a good idea. It will affect your transaction response times. And this is an example. Again, this chart's from Athene. This was real data from a client site. They had a number of VMs all doing the same job. Depending on who'd built them, they had 2 or 4 vCPUs. So this is a 4 vCPU, and this was on this axis here on the right-hand side, you can see the 4. That's 4 vCPUs. This is the amount of processing time it did, about 500 seconds worth of processing time every hour. And on top of that, this is the ready time that you can see. There's far more time spent waiting for CPUs than there actually was time spent processing. It's about double. So the way we worked it out, anything that would have taken about a second to process normally, if there'd been no concept of ready time, would take about 4 seconds. Okay, so it's having a huge impact on this system. This this VM was one of the ones with 2 CPUs. Same day, same host, same cluster, same environment, doing the same job. Again, it's doing about 500 seconds worth of CPU time, but it's only got about 150 seconds worth of ready time on top of that. So now we're talking about anything that would have taken a second takes 1.3 seconds. Great. I mean, not great that we have any ready time, but you're always going to have some contention for a shared resource. But it's not what we had before. And that's just by reducing the number of CPUs. We've halved the number of CPUs. We doubled almost sort of the chance of finding the CPUs that you want to use. So fewer vCPUs is better. I warned you there was an animation. I spent hours making this. I'm going to use it for years. So we've got something called the ready queue. So this is this blue area here. These VMs are in the ready queue. They're not waiting for anything else. They are waiting to be allocated CPUs to go and do something. And we've got a bunch of VMs that are off doing other things. Maybe they're waiting for I/O. They just don't have anything to process. Who cares? They don't want CPU at the moment, and I'm happy with that. So a number of VMs will obviously get moved from the ready queue onto the physical CPUs. Now, you'd normally have more than four. You'll have 32, 128 CPUs, whatever it is. It's just an example. So those move on. That guy can't get on. That VM, he can't get on. So although we've got 25% CPU available, we've got a VM that can't be processed, even though it wants to be. We're at 100% of the capacity that we can use at this point in time, despite only using 75% of the CPU. That's not where we want to be if we can avoid it. Now, some of those VMs, that VM might finish doing what it needs to do and it goes away, but we can move one of those two VMs in. Wonderful. Now we're now using all of the CPU. We're running the hardware as hard as we can as well. We're getting best use out of this thing. And then this guy turns up. Okay. He's in the ready queue. He's going to want to do something. Maybe VMs go away again. They've finished doing what they're doing. Maybe we shut them down. I don't mind. They've gone from the threads and they've gone from the ready queue. That guy's not going to fit. Even though we're at 50% CPU utilization in this example, that VM cannot be processed because there aren't enough vCPUs. And maybe these guys turn up with a high number of shares and they get straight in, not a problem. One of them leaves and so on, and VMs come and go, and the bigger VMs just can't get in. These small ones, they're nipping in and out, and that's great. But the larger VMs, there's no space for them. So even if we clear it all out, you're not going to get that guy on. Just one VM running. Sure, that guy with the low number of shares can get on there, but hopefully it's sort of illustrating the problem. The more vCPUs you give that VM, the more difficult it is, the more trouble there is finding those CPUs at the same time. Now, when we started with VMware, we just had ready time. There's now also something called co-stop, which is where you can sort of allocate one of the CPUs that a VM needs, but only for a few milliseconds before you have to schedule all the others. So if you schedule one and then you have to stop and wait for all the others to get there, then you accumulate co-stop time as well, where you have to stop everything to get that VM processed. So those are the two you're looking for. Ready time, definitely, there were not CPUs, and co-stop means you've got multiple vCPU VMs that are still suffering the same effect. They can't find all of the processing they need when they need it. And those things have a direct impact on your transaction times. So if you're seeing them, you want to do something about it. So like I say, ready time and co-stop, if you can find that in your metrics, that impacts on performance. You want to monitor it as well as CPU percent or CPU gigahertz, and avoid using high numbers of vCPUs. My sort of rule of thumb on this is if I'm seeing more than about 10% of an interval as ready time, then that's probably not good, and I want to do something about that to reduce it. We've spoken a lot about CPU, so let's talk about memory, because memory is the thing that tends to be the limiting factor on any cluster. You tend to run out of that before you run out of anything else. And it's not just the percent used, as it said, like CPU, we want to be able to compare memory utilizations across across different servers and so on. That's great because a megabyte is a megabyte. It doesn't vary. We don't have this whole times not linear problem going on. So that's great. But what megabyte? So we have a number of metrics that we use here. So I'll go through them. There's reservations. Okay, a virtual machine can have a reservation. So it might have 8 gigabytes of RAM, and we might have said it has a reservation of 4 gigabytes. That means whenever that VM wants to do anything with it up to 4 gigabytes of RAM, it gets it. There's no question, there's no sharing of that memory. When it wants it, it gets it. It's not always held in reserve. That memory can be used if that VM doesn't want it. But as soon as it wants it, it gets it up to its reservation. There are things called resource pools as well, and they can be given reservations. So you might give a resource pool a reservation of 8 gig. It might have 2 VMs in it, each with 8 gig of RAM assigned to them, and they can use that first 8 gig as much as they want. Again, it's reserved for the things in the resource pool. When they want it, they get it. As well as a reservation, you have a limit, and the limit's fairly obvious. That's, again, you could have, say, an 8 GB VM, but you could apply a limit that's smaller than that. So you might say the limit is 4. There could be reasons for doing this, but it tends not to be a good idea. Why would you do this? If you're going to limit it, just make it smaller. But sometimes you put the limit on the resource pool rather than on the VM. So you might have a resource pool where sometimes some of the VMs want to use all the memory, but not all the time. So you set a limit on it because it's, say, pre-production, so it can't affect the production systems. Ballooning is an interesting one. It's a concept we don't have to worry about in the physical world. So ballooning is where there's a shortage of memory within the cluster or on the host the VMs are running. And so VMware needs to find memory that is available to use when something else wants a page of memory. So what it will do is it will inflate a balloon inside the operating system of VMs that haven't been very active in their memory. Because an operating system, an application might use lots of memory within the operating system. And when the application says it doesn't want that memory anymore, nothing happens to that page of memory. It doesn't get zeroed out. So the hypervisor doesn't know whether an operating system still wants that for an application or not. By inflating a balloon in the memory of that virtual machine, we can force the operating system to release all of those pages to that balloon. And anything we know that matches the memory that we've stored in the balloon, we know is actually available memory that we can use elsewhere. Obviously, if we continue to expand the balloon, it not only gives up all its free pages, it then starts to page out itself. So the operating system will start to take memory from other processes and put it onto disk. That's not great because you get the standard paging that we get within an operating system when it's busy. And if we go even further with needing more memory on the hosts, the hypervisor will start to just randomly page out pages to disk as well, which is really bad for performance. But the balloon itself, it's inflated in the memory in the VM. It's pinned into what it thinks is physical RAM, so it pages other things out, uses free memory pages to host that balloon. That helps the hypervisor identify memory that it can use and give to other VMs. Shared pages are great. Shared pages is where you've got, say, a couple of hundred VMs all running the same operating system. There's a big chunk of that memory is going to be shared. It's going to be identical pages of memory between all those virtual machines. So what the hypervisor does is it goes through, and every 20 seconds, it checks to see if it can find any duplicate pages of memory. And when it does, it only stores a single copy and it gets rid of the duplicate. If two VMs have got a shared page and one of them edits it and the other one doesn't, then sure, it has to create a second page again. But if you've got VMs that are all the same operating system, they're all patched at the same levels, they may be pulling up the same databases, there's a good chance you're going to have a lot of memory that's identical, that can just a single copy of it can be stored, and then all the VMs reference that same page. Active memory, again, it's a sort of a 20-second thing, but it's the amount of memory that a virtual machine has accessed within the last 20 seconds. Now, it could be that that VM is accessing the same set of memory every 20 seconds. So maybe its active memory is 200 meg, and it's always accessing the same 200 meg over and over again because that's the stuff it's working with. Or it could be a different 200 meg every 20 seconds. So it doesn't necessarily, it's not a perfect measure, but it does show you how much space that VM needs, absolutely must be in RAM. Because if the active memory has been paged out, then you're really in trouble. But that's what it shows. It shows how much memory that VM is accessing on a 20-second sort of basis. So you want to have at least that available for that machine in RAM, and preferably some more, double, maybe 3 times, depends how much it is. You've got to play that a little bit by ear, but that's what that means. The memory available for VMs, well, that should hopefully be what it says on the tin. There's some memory that's needed by the hypervisor. There is memory that's left over, that's the memory that's available for the virtual machines to use. Okay, so if you put 16 or I don't know 128 gig in a host, you won't have 128 gig to use for all the virtual machines. A section of that will be needed to run the hypervisor, but it's probably not a lot. Another chart from Athene. So this is sort of a typical type of graph we might do to look at a virtual machine. We can see things on here. So that blue is that overhead I was just talking about. There's always some overhead that's associated with running a virtual machine that isn't memory that virtual machine can address. So you can see a sliver of that. Used there in the sort of salmon color, that's what we call active memory. So that's what's active. We definitely need to make sure there's space for that in the RAM of the host. Shared memory, there's a huge chunk of shared memory. And that's great. We want lots of shared memory. It means that we've put things that's the same together. We're being nice and efficient. And then the pink line is host memory consumed by the VM. So you can see as shared memory goes down, whatever's happening, we're editing pages of our memory that maybe other VMs aren't editing that were shared. So shared memory goes down, host memory consumed goes up because we've no longer got these shared pages. We've now got unique pages. And then at the end of the day, it seems to have all come together nicely again towards the end. This one's an example of the balloon driver suddenly coming into use. So the actual name of the process as you see it in Windows is VM mem control. So that's what we call it, but it's the balloon driver if you're talking VMware speak. And you can see suddenly that ramps up and then stays pretty flat on this system. We've got a limit of memory. We've got some reservation. Well, reservation's tiny. And you can see the amount of memory consumed by the host. So we get a sudden spike in consumed memory. And the balloon driver goes up at the same time. And we swap some of the memory for this VM out to disk. So this memory swapped is what the hypervisor is doing. So that's bad. The less swapped memory we have, the better. And the fact the memory balloon driver has been used and stays active, that's not great either. A spike that goes away, not a problem. So what happened? Well, if we look at the cluster rather than just looking at the individual VM, we can see something interesting event happens at that sort of time in the morning. Total usage of the available memory for the cluster goes up. There's this sudden lump and then it sort of tails off in a sort of gentle curve. Shared memory nosedives and then comes up and then it's got a gentle curve sort of the other way. The amount of memory used by mem control goes up, obviously, because we've started to use more memory, so now we need to find memory. And swap space usage goes up and then starts to tail off. What happened? Well, they ran Windows Update against a whole bunch of their systems. So they all started to have unique pages. They all went down. They all came up. When they come up, we don't know if the page of memory is shared. So that's what this sort of gentle curve is. As it discovers more and more shared pages, you have a greater amount of shared memory. You've got a gentle curve as it no longer needs to find memory and so on. But that's the kind of thing that looks like. If you shut them all down and restart them all, you get an event that looks a bit like that. Suddenly we need lots of memory because the shared memory is not shared. And then over time, it settles back out again. I spoke about some storage metrics. So we get some nice latency metrics. Again, we're looking at storage as much as we can from the hypervisor, from the ESX host or vCenter, rather than from the operating system because of that time slicing problem. So when we look at things like kilobytes a second and I/O time, it can be wrong. And by how much, we're never really sure. So VMware has all of that information, how many kilobytes went through, how many I/Os happened per second, and it also gives us these levels of latency. So we get queuing, device, and kernel. Okay, queuing is device and kernel weren't fast enough for all the I/Os that we wanted to do, so we had a queue. Right, so it's an indicator you've already got a problem. So device and kernel are really the two that are telling us what's going on, rather than the after effect of a queue. Device is everything that's happening outside the hypervisor, and kernel is kernel time that could be taken up using performing the I/O. So if I pull this up again, it's a chart from Athene, and we're looking at data for a host, and we're looking at the individual CPUs, and I was just talking about storage. Well, I also spoke about kernel. What we can see on this chart is we've got 8 CPUs, 4 of them in the red and sort of purples. They're nicely tightly tied together. They're acting together. And then you've got another 4 where 3 of them are tight together and 1 of them isn't. Processor 0 is a special case. Processor 0 runs the kernel. So if processor 0 happened to be very busy, suddenly you start to get lots of kernel time in your I/O, because I/O has to go through the kernel before it goes out to a data store. Things have got better with sort of direct paths through to disk if you're doing sort of direct management and things like that, but it's still a thing. If your kernel gets busy, your I/Os will have to slow down whilst it sorts out what it's doing. And that's why processor 0 tends to be busier than any other processors that you would see it sort of responding with. Normally, your charts will look something like this if you're looking at latency. It's almost all device latency. There's a little bit of kernel every now and then, but the bulk of it, the green would be total, blue would be device, and you can see they pretty much go along together. There's very little queuing, hopefully, but if there was a difference between device and total, I would expect it to be a bit of queuing going on, and we'd maybe need faster disk. So, headroom in VMs. This is because it's one of the common questions you get from the business. How many more VMs can we fit in our environment? We know we've bought this VMware stuff, and then we know it runs VMs, and we want to know how many we can do. Okay, fine. Now, it makes some traditional capacity planners a bit sort of uncomfortable because we like to talk in very certain terms. And when you say how many VMs can fit in a space, it's equivalent to saying how many balls used for a variety of sports can you fit in an Olympic swimming pool, right? We're all used to this kind of, this swimming pool can hold 50,000 such and such as well. If we don't know the sports that we're playing and we don't know what balls we've got, and we don't know. So we have to estimate. If you've ever had to deal with looking at what the business forecast was to what happened in reality, you know that the business is okay with estimates, and you've just got to estimate it and go along with it. So we're going to come up with that number, but we need to make some decisions. We can't just pluck out of the air a number. We're still going to do some calculations to try and figure it out as best we can. First thing we have to figure out is what's the size of our cluster. This might sound like an obvious answer, but are we allowing for one host to fail? Presumably we want to allow for the largest host to fail, but you might have another opinion. Maybe you're allowing for 2 hosts to fail, which are the 2 largest hosts. You've got to go and identify those before you can decide how large your cluster is. And of course that could change on an almost daily basis if people are adding hardware, taking away, depends how big your environment is. Then you've got to decide how you're going to determine the size of your virtual machines. I've spoken about megahertz and megabytes. That's what I would use. A number of sites don't want to do that. They are really keen on getting good CPU performance, and they have in their mind a vCPU to physical core ratio. Some of them that's 1-to-1. Anytime a CPU wants to get on there, we want it to be able to do it. Okay. That's going to determine how you size your cluster. I think that kind of diminishes the effect of VMware somewhat, but if they want to use the environment more than the ability to compress stuff down, that's great. Or do you want to use something else? I mean, you decide, but these are decisions that need to be made. How are we deciding the actual size of our cluster? Are we allowing for host failures? How are we actually going to decide what we want to call the limiting factor? Can you calculate the size of your average VM? Because I would do this on the size of an average VM. Okay, because you're making an estimate. So presumably we're going to carry on having the same sort of sets of VMs that we've had before. Or you could come up with a small, medium, large and a ratio and decide how many of each you're going to have. It's not a simple case of just going and looking at the numbers. You've got to answer some of these questions, decide how you want to do it first. Now, obviously, you need to get that data from somewhere. I would advise that you buy Athene and use that, because that's obviously what I would do. But there's nothing to stop you from writing stuff down manually from vCenter, apart from the fact it's a manual process. You're going to make mistakes. And you want to do it all the time to get some really good answers out of this. Continually running a manual process is painful. The other thing we need to do is we need to be able to identify a good peak. It's all well and good looking at the last 5 minutes and writing down those numbers, but is that relevant? Is that 5 minutes a good period of time? We need to be able to look at a period of data, understand the best point in time to take, and use that to do our calculations of the size of our average VM, preferably a peak when nothing unusual was going on. And hopefully we want to be able to inject our future project requirements, inject reservations for, we've got a project coming down the line, it wants 10 VMs. Let's make sure that we've got space for that to go. We're picking a good peak. If you're a capacity manager, you should be able to do that from a chart relatively easily. But we don't want this big one here. That's clearly an anomaly. This looks like an anomaly to me as well, as does that. Maybe there's something real, we might have to go and investigate, but if all I'm faced with is this chart, maybe I take that one, or maybe I take this one as our true peak. This one looks like a nice distribution curve that we would expect on a sort of regular basis. So I might take that sort of period to make my definition with. Then I've decided, I've pulled out my data for the size of my cluster, the size of my largest host. I've taken one away from the other. I've output the size of my average VM by doing that calculation and sticking that out as well. Then I've divided what's left of my cluster by the number of VMs, taken away the number of VMs we've currently got, and we find out that there's space for 6. This is a tiny cluster, for an example. Okay, and you're thinking, why is it in Excel? Didn't you have a tool that you were talking about? Yes. Yeah. But the reason I've wanted to put it in Excel is so that people can enter their own values into this plans sheet that I create. So they can, project managers, other people have access to that as a spreadsheet. They can put in the name of their project, they can put how many VMs they want, what date they think it's going to happen. We can put that in as if that was a number of VMs that existed from our average VM calculation, and then we can see how many VMs are going to fit or not. We do it both by CPU and memory, so you compare, which is the smallest, which is the worst case, is it CPU or memory, and that's why it's saying you can fit minus 10 VMs on there based on memory, so maybe we upgrade memory rather than upgrading the host. But it's going to give us that answer. But it's all about answering those questions first, calculating your average or choosing the sizes that you want, deciding what you want to use as the side of your cluster, and then pulling that all together. What I like to do is then loop that back round. So I've got those answers, import them back into Athene through our integrator feature, and plot and trend that. We might not actually be adding and taking VMs away here. This may very well just be an indication of our ability to do work, how busy we run the VMs on any given day, whatever it is. But it gives another view of that in terms of this is the number of VMs available in the cluster over time based on those metrics that we've just been through. So a quick roundup from me. Ready time is really important, co-stop as well. The reasons for that is all caused by that time slicing situation where time isn't stable anymore. And fewer vCPUs is better. Only give it the number of CPUs it's actually going to use. Memory's got all sorts of metrics that relate to it, but if you see a lot of ballooning and swapping, then you've got issues. Check out active memory and make sure that there's always enough space for all of the active memory to be in RAM on the systems. Disk latency, some really nice numbers in there to see a bit more detail about what's going on. Know how you want to size your clusters before you start trying to report back on what size they are. Be able to calculate your average VM and find good peaks, and then trend your results back from that, as it gives a really nice view of, are we just losing space just with the amount that we're running the VMs, or are we losing space by adding VMs and things like that are going on into the future. Right, that's me done. I don't have access to the Q&A panel. I know some of the other guys do, so I think I'll hand over back to Rich. Rich, you've got a couple of slides to go through, and then if we've had any interesting questions, we can cover them off at the
I
end.
do. I do, and we have a really cool offer at the end. So if folks are still on, I recommend you stay on if you're interested in getting what's essentially a free assessment of your VMware capacity management environment. Athene is our capacity management solution. Athene and Athene Cloud are relied on by the world's leading companies, automates everything, including the capture, storage of data, creation of reports, provides predictive analysis to help sizing of infrastructures, includes all the platforms you could imagine, including VMware, mainframe, IBM I, Unix, Windows, etc. Athene Cloud takes that world-class solution and puts it in the cloud. So there's no need to provision, maintain, and manage your Athene hardware. It's a secure transfer of data from your environment to Athene in the cloud. Ongoing management of historical data so that you don't keep detailed data for thousands of systems for years on end. It manages it to some degree based on what you're interested in. And then on top of Athene Cloud, you can add a managed service from experts within SyncSort who have been doing capacity management a long time. So if you don't have if you need to augment your staff, or if you don't have a staff and you still want to provide capacity management services, we can do that for you as part of the Athene Cloud solution through our professional services. So, our professional services, we're looking to help you achieve your maximum ROI. We can create reports for you, regular capacity plans, strategic recommendations, leverage our expertise. Our consultants, our capacity management consultants, many of them who've come from Metron, have decades of experience in capacity management. I'm the marketing guy, and I've been a capacity manager for 20 years. So, we all are experienced in this area, and we do, extremely well. Why Athene? Number of things here. You'll get these slides later. I'm more interested in talking about the offer since we're coming up to the top of the hour. Let's move on to the. This slide's. Go back to that slide.
Sorry.
Phil. No, it's fine. This bit here talks about, what Athene can do for you. And so global financial services firm, you can save money, meet SLAs. This company avoided over 100 outages and saved about $4 million spent in 3 years by having a mature capacity management process with Athene in place. So, it helped them really provide recommendations on which hardware to buy. There's a number of instances where they chose to buy smaller hardware because they really didn't need the excess capacity, help them resolve incidents faster, and really let them become more strategic and less reactive. So, Athene has really helped organizations become very good at capacity management, saving money, meeting SLAs, getting return on investment. Go ahead, Phil. All right, so the next step coming out of this, there is a handout that you can download. It's a PDF that should be attached to your control panel within GoToWebinar. And what we're going to do, the handout actually describes our VMware capacity management assessment. It's 2 days consulting, one on site, with a presentation of results and recommendations. So it's formal capacity management process recommendations. There's an idle capacity plan template that comes out of this. A gap analysis for the tool capabilities. So we'll look at your existing tools. We'll do a gap analysis around those tools. We normally charge about $5,000. It's 2 days of consulting, but we'll do it for free for the first 5 companies that respond. So if you contact me at the email address that you see on the slide, and you'll get these slides, so you'll have my email address, rich.frohnheiser@syncsort.com. If you respond, we will arrange for this to happen for you, and it'll include a day of us coming on site. We'll take some information from a bunch of your stakeholders. We'll interview some stakeholders. The details are in the PDF that is attached to GoToWebinar. So if you look at that PDF, it'll show what we'll do. It'll show what we expect from you in order to make this successful. and the first 5 companies that reach out, we will do this for you for free, and provide some value to you. So I would really recommend that if you're looking at, if you're interested in an expert view of how your capacity management process is functioning, how well you're doing VMware capacity management, and we're a cross-platform solution. So if you have VMware, you likely have mainframes, IBMI, Unix, Windows, etc. So we'll also evaluate how your capacity management for VMware fits alongside of the rest of your capacity management process. So really excited about that, because it's an offer we've not made before, but we're going to do that for the first few companies that respond after this webinar. And I believe we finished right on top of the hour.
Yeah, I'll take one question. There's a bunch of questions, and I think Amanda said, we'll answer them in a blog post. I'll take one. I mentioned ready time goes over 10%. We probably want to think about doing something, and the question was, what is there one for co-stop, which I also mentioned. I would say if the combination of them gets up to about 10%, that's taking 10% of your transaction time on that server to do things that you don't want it to be doing. It's time to look at it and make a decision.
Okay, Phil. Why don't we handle? There's really 3 questions. 3 questions I have here that you could probably answer fairly quickly. Those that can hang on, we'll take another minute. So what statistics level does vCenter need to be set at for Athene?
Okay, so Athene, we don't really mind what the statistics level is on vCenter. The way we collect the data, we get all the data that we're looking for at any of the statistics levels. So you don't need to ramp it all the way up or anything like that.
You mentioned guest operating system metrics and the dangers with relying on those. Is there any benefit you can see from capturing and using those guest operating system metrics?
Yeah, that comes up quite a lot. It can be useful if you want to know what's going on inside the VM. So it's one thing knowing how much overall did the VM do as a black box, but sometimes you want to know why. What process was it that made it particularly busy? Now, maybe the numbers are not 100% accurate, but you can compare, what SQL Server was doing against IIS on a server, right? And if one's twice as big as the other, that's probably the one that's caused the increase, and you can compare them across time and things like that. So there is worth in that, not so much for the sort of capacity of VMware side, but for the looking into performance problems and understanding how that VM is using its time.
Okay, so one last question. You showed a lot of VMware reports, and the question that came in was, can Athene integrate other platforms into reporting alongside of VMware?
Yeah, so Athene's almost sort of platform agnostic. We'll pull in data from anything. We have data capture for all the standard operating systems, Windows, Unix, Linux, the mainframe. We can pull in data from iSeries, IBM Power systems, storage platforms, networks. We'll pull data in from anywhere, really. So yeah, and the idea is we can pull that all together and start to represent all sorts of things like services, groups of systems that work together and their capacity, rather than just individual servers and things like that. Try and get a bit more intelligence into that.
All right, Phil, thank you very much. Great presentation today. Again, reminder, the VMware Capacity Management Assessment, reach out and we'll get that organized and arranged, in the next few weeks or so. And want to thank everyone for coming.